Let's take a look at this system. We want to begin always by choosing a variable to eliminate. And in this particular instance, it's just as easy to eliminate x as it is to eliminate y. I'm going to go with the elimination of y because I have a negative y in equation 1, equation A, and that's going to actually make my work easy-ist, but I could just as well have chosen to eliminate x or z. You just have to make a choice, and you do want to make the easiest choice. So I'm going to use equation A and B. And I notice that I have a negative y in equation A and a negative 3y in equation B. So if I multiply A by negative 3, I'll have a positive 3y in A and a negative 3y in B, and so I'll have opposites. So I don't need to change B at all. So negative 3 times equation A is negative 3x plus 3y minus 9z equals negative 3. And you just want to check that you really properly multiplied every term by your non-zero multiplier, which in this case was negative 3. Then I'm just going to copy B. 2x minus 3y plus 4z equals negative 1. And check that you've copied correctly. It's so easy to make a mistake. So the equation that I get, I'm going to call D. Negative 3x plus 2x is negative x. The y terms cancel out. And I have negative 9z plus 4z is negative 5z. Negative 3 plus negative 1 is negative 4. So I'm going to eliminate y again. And this time I have to bring c into the work. So whatever variable I eliminate the first time, I want to bring in that third equation and eliminate that same variable again. And I'm going to use A and C. I could also use B and C, but using A and C gives me my easiest option. I'm always looking for the easiest option because the less I have to do, the less chance I'm going to make a mistake. So I notice in equation A, I have a negative y. In equation C, I have a positive 2y. So if I multiply equation A by 2, that'll give me a negative 2y in A and a positive 2y in C if I don't make any change to C. And I have opposite coefficients on my y terms. So 2 times equation A gives me 2x minus 2y plus 6z equal 2. And then I'm going to just copy equation C. I want to make sure I do that correctly. All right, and I notice that the y terms are opposite, so those are going to add to 0. I'm going to call this equation E. 2x minus 3x is negative x. 6z minus 11z is minus 5z. 2 minus 6 is negative 4. So I see this is the exact same equation as equation D. That means I'm dealing with a dependent system. And if I'm not convinced of that, I can add D and negative E if I need to go further to be convinced. So D I'm going to leave unchanged. E I'm going to multiply by negative 1. And I see when I add these together, all terms cancel out in one equation with those of the other. So I get 0 equals 0. This work involves all three equations. This system is dependent. Now notice that this is a type of system where I can write the solutions in terms of z. And I'm going to go to equation D to do that. All I need to do is solve this for x. So I'm going to add 5z to both sides of the equation. Starting with equation D, so I wind up with negative x equals 5z, and I think I'm going to write this, I'm going to write this in the other order. I'm going to write it as negative 4 plus 5z. And then I multiply both sides by negative 1 to get x, and I get 4 minus 5z equals x. So that's my x. So I'm going to go to equation A, which is x minus y plus 3z equal 1. X minus y plus 3z equal 1. And I'm going to let x be 4 minus 5z. And I'm going to solve this for y. So I'm going to add a y to both sides. And when I do that, I get, and I'm going to also combine the like terms. So minus 5z plus 3z is minus 2z. So that equals y, 1 plus y, or y plus 1. And I'm now going to subtract 1 from both sides. So 3 minus 2z equals y. So the system is dependent, and the solution set consists of all ordered triples, where the x is 4 minus 5z, the y coordinate is 3 minus 2z, and the z I can let equal any real number. So I get infinitely many solutions, and I have total freedom to pick a real number value for z, but once I pick that, then the x is determined by 4 minus 5z, and the y is determined by 3 minus 2z. So that's infinitely many solutions, but they have a very specific form. So that's how I would work problem 7. All right, let's take a look at problem 8. In this problem, I am doing the same thing I've been doing. I'm attempting to solve this system. And I'm going to choose, because I see I have a negative z in equation B, I'm going to choose to eliminate z first. That's going to be my easiest choice. I'm always looking for the easiest route because that minimizes the chance that I'm going to make an error. So I'm going to eliminate z, and I am going to use B and A. So A, I notice I have a 2z. In equation B, I have a negative z. So if I multiply equation B by negative 2, I'll have a 2z in A and a negative 2z in B. So I'm just going to recopy A. Every term in B, I'm going to multiply by negative 2. I mean, just by 2, I'm sorry. It doesn't need to be negative. I've already got the signs that I need. So 6x plus 8y minus 2z equals 30. So the z terms cancel out, and I have 8x plus 3y equals negative 4. I'm going to call that equation D. I'm going to eliminate z again. So whatever variable I eliminate the first time, I want to eliminate, in the general case, I want to eliminate that same variable a second time. This time I've got to use equation C. Since I've got that negative z in equation B, I'm going to use B and C. But I also could have used A and C. So I notice B, the z term is negative z, and C, the z term is 3z. So I'm going to multiply B by 3, and I'll have a negative 3z in B and a positive 3z in C, which is exactly what I'm looking for. So I get 9x plus 12y minus 3z equal 45. And I'm going to add to that equation C, which is 7x plus 3y plus 3z equal negative 17. So I'm going to add those together. And I'm going to call what I obtained here equation E. So I get 16x plus 15y equals 28. And I'm going to focus now on eliminating x. I could really eliminate at this point x or y. And of course I'm going to be using equation D and equation E. So I'm going to do negative 2D plus E. And that will eliminate my x term. So negative 2D gives me negative 16x minus 6y equals 8. E is 16x plus 15y equals 28. So I notice that when I add these together, of course, since I was eliminating x, that's eliminated, and I get 9y equals 36. So if I divide both sides by 9, I get y equals to 4. So I've got y. And I can use either D or E to find x. I'm going to use D. 8x plus 3 times 4 equals negative 4. 8x plus 12 equals negative 4. I'm going to subtract 12 from both sides. And I get 8x equals negative 16. Divide both sides by 8. And I obtain x equal negative 2. And I'm going to use equation B, 3x plus 4y minus z equal 15. And I'll just make sure I copied that correctly. 3x plus 4y minus z equal 15. And I'm going to replace x with negative 2, y with 4, and this will allow me to find my z. So negative 6 plus 16 minus z equal 15. 10 minus z equal 15. Subtract 10 from both sides. Negative z is equal to 5. Multiply both sides by negative 1, and z is negative 5. So my solution set then is a set of ordered triples that contain this one ordered triple, where the x is negative 2, the y is 4, and the z is negative 5.